Okay, so we're going to look at some more properties of exponents. We covered most of this in the first lesson, but we're going to just review real quick. So we're going to review the properties of the exponents, and then we're going to look at some examples that put more of them together. So whenever we have a base b, if we have b to the nth power and we multiply it by the same base b to the nth power, then we're going to add those exponents together, and we're going to have b to the m plus n. So for an example here, if we have x to the 8th times x to the 4th, then we add the 8 and the 4 together and we get x to the 12th. So then if we want to divide those instead of multiplying, if we have b to the m over b to the n, then we're going to subtract instead of add those. And we're going to have b to the m minus n. So if we have x to the 8th, instead of multiplying, we're dividing by x to the 4th. Then we're going to get x to the 8 minus 4, and we're going to have x to the 4th. If instead we take our base to the mth power, and we raise the whole thing to the nth power, then we're going to multiply those together, and we're going to have b to the m times n. So if we have a cubed, and then we want to square that whole thing, and that was a to the 6th. If we have two things inside our parentheses, if we have ab, and we raise that to the nth power, then that's going to kind of distribute to both of those, where we have a to the m, b to the m. So if we have xy, and we square that, then that's going to be x squared, y squared. And then our next one's kind of an extension of this. If we have a over b, and we raise that to the mth power, well, we can think of a over b as a times 1 over b. So it should be pretty natural that this is going to be a to the m over b to the m. So if we take y over 3 and we square it, then we're going to get y squared over 3 squared. But then we need to reduce that. If we have small numbers or small powers, we always want to simplify it. So we have y squared over 9. Then just a couple other things. If we have some base to the 0 power, that's going to be 1, no matter what our base is. So if we have 3x plus 2, and we raise that to the 0th power, then that's still going to be 1. It doesn't matter what's inside our parentheses here, it's still going to come out to be 1. And then the last property that we covered was if we have b to the minus m, that equals 1 over b to the m. So if we take x to the negative 1, then that's going to be equal to 1 over x to the first power, which is just x. Or, in the case of fractions, if we have 2/3 to the negative second power, then that negative sign, to get rid of that, we flip our fraction over. So we get 3/2, but then we have a positive exponent with just the 2. And then we can use our other properties and we can distribute that in there. But we're not going to worry about that right now. So we have 6 examples here where we're going to take some of these properties and we're going to put them together. So the first one was if we had 2/3 and then we square that minus 9 to the negative first power. Well, we're going to use the distributive property in the fraction here, and we're going to have 2 squared over 3 squared. And then over here we're going to turn that 9, we're going to turn it into a 1 over 9. And then we need to simplify the 2 squared to a 4 and the 3 squared to a 9. Oops, sorry about that. To a 9 minus the 1 over 9. And we have a common denominator, so we can just subtract across the numerators. So we have 3 over 9. And then we can reduce that, and that'll just be 1/3. just adjust that a little bit again. Alright, so then in our second example, we have 6x to the negative third, y to the fifth, and all of that's going to be over 10x to the positive third, y. Okay, so when we look at this one, we're going to have a couple different properties going together. We can see right away with the 6 and the 10 that those are going to cancel, and we're going to get 3 over 5. We're going to divide 2 out of each of those. This x to the negative third, we're going to need to move that to the denominator. So we're going to take it out of the numerator, and we're going to move it down here by the other x to the third. And then the y's, we're going to cancel this one out of the denominator, and we're going to subtract 1 from the one in the numerator. And we have y to the fourth. Okay, so then we need to combine our x's on the bottom. And what we get is we have 3y to the fourth over 5x to the sixth. So that's the second one. For this third one, we're going to be looking at c squared d, and that whole thing to the third power, and then we're going to multiply that times 3c to the negative first, d to the second, and then we're going to square that whole thing. So the first thing we probably want to do is we want to distribute the exponents on the outside of the parentheses, and then we can collect terms together, or collect the pieces together and combine the exponents. So we're going to have c to the 2 times 3 and d to the 1 times 3. And then over here, we always want to remember when we have a constant inside our expressions that those exponents apply to those too. Those are kind of easy to leave out sometimes. So we're going to get the 3 to the 1 times 2. C, we're going to have a negative 1 times 2. And D, we're going to have a 2 times 2. So we're going to want to simplify those exponents. So we're going to have c to the sixth, d to the third. We're going to multiply it by 9, which is just the 3 squared. Then we have c to the negative second, d to the fourth. So then we want to look at these c's here and these d's here, and we want to get those put together. So let's go ahead and let's grab our 9 and put it out front. And then c, we're going to have c to the sixth, c to the minus second, and then d to the third, and d to the fourth. Okay, so when we have the same variables with their exponents, we want to add those together when we multiply them like this. So that's true even when we have this negative exponent like this negative 2 here. So we're going to take and we're going to have 6, and it's going to be minus 2. So we're going to have 9 c to the fourth, and then for the d's we have 3 plus 4. We're going to get d to the seventh. Alright, so that's our final answer on that one. For the next one, we have x to the fourth over y squared, or y to the negative second power. And then we're going to square that whole thing. And then we're going to multiply that by 5xy to the fifth. Alright. So we want to distribute this exponent up here out to the other parts. So we're going to have x to the fourth squared over y to the negative second. We're going to square that. And we're going to keep this other part out here for the time being. Okay, so then we want to use our multiplication property of taking a variable to an exponent to another exponent. So this is going to be x to the 4 times 2 is going to be 8. And then we're going to have x to the, or y to the negative fourth times 5xy to the fifth. But this y to the negative fourth is down the denominator here. So we're going to need to move that up. So we're actually going to get here, when we rearrange things, we're going to take our 5 and we're going to put it out front. Then we have our x to the 8th times another x, and our y to the 5th, and then we're going to bring this other one in here. It's going to become y to the positive 4th. So then we just need to combine those variables, and we get 5 x to the 9th, y to the 9th. All right, the 5th one, we're going to have 4 x to the negative 2, y to the 6, over 2x to the 4th y. But this one we're going to take and we're going to square that whole thing, and then up here we're going to cube it. So we're going to start, and we can distribute our exponent from the outside again on the top and the bottom separately. So we're going to have 4 cubed x, when we multiply the 2 and the negative 3 we get negative 6, and y to the 6 times 3 is going to be y to the 18th. And then down here on the bottom we're going to get 2 squared, and we're going to get x to the 4 times 2 is going to be 8, and y will just be squared. So moving on, we have this x up here to the negative 6th power, and we want to move that down. But then we also have this y down here, and we're going to want to subtract the exponents on the y's. And then we also need to simplify here a little bit. But we can look at something else here before we simplify too much. We're going to leave this 4 to the 3rd here. And then we're going to take our y to the 18th. We're going to subtract this 2 from the exponent in the bottom. So we have 18 minus 2. This 2 squared, that's just a 4. Alright? We know 2 times 2 is 4. But this is going to let us cancel with one of these 4's up here. And then we're going to have our x to the 8th that was already down in the denominator, and that x to the negative 6 that was in the numerator, we're going to bring it down. So 4 to the 3rd power divided by a 4, that's going to leave us a 4 squared. And then we're going to have our y to the 16th here. And then this 4 down here in the bottom is gone now, so we're just going to have x to the 8 plus 6 is 14. So then we just need to simplify our 4. We're going to have 16 y to the 16th over x to the 14th. And that finishes that one up. And then our last example that we have negative 8, a to the 6th, b to the negative 3rd, c to the 9th in the numerator. And then in the denominator we have 16 a, b, c to the 9th. And we're going to take this whole thing and put it in parentheses. I'm going to put that to the negative 3rd power. So normally when we have a fraction and a negative exponent, the first thing we want to do is we want to flip that over. But first we want to take a minute and look and see maybe how we can simplify this sum. This c to the 9th we have in the numerator and denominator, so we can cancel those out. So that leaves us a little bit less to worry about. So when we rewrite this, we won't have the c to the 9ths. We can also cancel with the 8 and the 16, just like a normal fraction. We divide both of those by 8. That's just going to leave that negative sign in the top and a 2 in the bottom. And then here we need to move our a's up and combine our a coefficient, or our a exponents. So that'll be a to the 6 minus 1. This b we want to move down to the denominator. So we're going to have that first b, and we're going to multiply it by that b to the 3rd. And then this whole thing is again going to be the negative 3rd power still, because we haven't done anything with that. So we have negative a to the 5th over 2b to the 4th. And this whole thing's to the negative 3rd power. Now one little trick that I like on this is that since we have this negative sign here, we can take that as another part of it, and we can distribute our exponent to it. And then we can have positive stuff to work with inside of here. Okay, so we're just using that distributive property of the exponents. And this is nifty because whether we have -1 or -1 to the negative first power, which is 1 over a -1, that's still just a -1. So then we just need to check and see. If this was an even number of exponents, then they would all cancel out. But since it's odd, we're going to have one left over. So what we get is we're going to have negative whatever this part comes out to be. So then we want to get rid of this negative in the exponent up here. So we're going to keep our parentheses, but we're going to flip our fraction. So we have 2b to the 4th in the numerator, and then we're going to have a to the 5th in the denominator. But now it's going to be the positive third power because we flipped it over. So then we need to distribute the third power here. So we're going to keep our negative sign. We don't want to lose that. We're going to have 2b to the 4th to the third power over a to the 5th to the third power. So I'm going to come up here. So then we're going to distribute that inside of there. So we're going to have 2 to the 3rd, and then we're going to have b, and we're going to use that multiplication property. So we have b to the 4 times 3, and that's going to be over a to the 5 times 3. Oops. So then we have our negative sign still, the 2 cubed, that's going to be an 8. Then we get b to the 12th, and then in the denominator we have a to the 15th. So that one was kind of a long example, but I think between these 6 examples, you guys should be getting a really good feel of these exponent properties, and remember they're going to be really important to us in the lessons coming up.